Hello, in this video we'll learn about polynomial function as a product of linear factors. We're going to see this example. Given the function p of x squared plus I minus 2 times x minus 2I with a complex 0 x equal negative I. Use the given 0 and synthetic division to determine all the zeros of p of x. So we want to know all the zeros of p of x using synthetic division. Of course you could factor this by distributing x and factor by grouping, but we're going to try to use synthetic division. It's given that x equal negative I as is one of the zeros, so the coefficient for this polynomial x squared has a coefficient 1, the x has the coefficient I minus 2, and the last constant term is 2I. So using synthetic division with the roots or the 0 is negative I, and we're going to bring down 1 first. 1 times I is negative I. Then we add I with the negative I cancel out and we have minus 2 left. So minus 2 times I, that will give us positive 2I, and when you add them you get a 0. So remainder is 0, and therefore negative I is a 0 for this polynomial. And now what's left is a factor, which is 1, since this one has x squared coefficient and this one was x. So down here it's going to be x, and this become the constant term. Minus 2 become the constant term. So p of x can be written as x plus I, because negative I is a 0, so the factor is x plus I, and then 1x, or just x, minus 2. Factoring it this way, so we could find that all the zeros for this polynomial set the polynomial equals 0. That will give us either x equal I, negative I, which we already know it's a 0, or x equal 2. So we'll try the next example here, and it's the same question, except that we have x to the third. So we're gonna try to use the zeros and synthetic division to determine all the zeros. So we have coefficient is 1, and then negative, I could say negative 3, negative I. I'm distributing this and negative here, and then the same here. I would say negative 4 plus 3I, and the last term is 4I, constant term. And the 0 is x equal I. So we multiply 1 times I, give us I, and when we add it will be negative 3. Negative 3 times I is negative 3I, then adding them will give us negative 4. Negative 4 times I is minus 4I, and when we add them is a 0. So we know that x equal I is a 0, that's why the remainder is 0. And since this was x to the third, and here it was x squared and then x, so the factor is x squared, negative 3x, and the constant term negative 4. So right now I see that p of x can be written as x minus I times x squared minus 3x minus 4. I see that this can be factored as x minus 4 times x positive 1. We have minus 4, and plus 1 is negative 3. Now if we set this polynomial equals 0, now it's already factored, and to set it equal 0 we get either the zeros are either x equal I, or x equal 4, or x equal negative 1. So finding all the zeros are I, 4, and negative 1 using synthetic division. And I hope this is helpful.